Hello everyone, you are welcome to this class. So in this class, we want to look at algebraic processes. So we'll be looking at the following objectives. So the first one is meaning of algebra. Then we look at some key concepts in algebra. Then we look at how to simplify expressions. Now when we talk about algebra, we're talking about using letters of alphabets or symbols to represent numbers. Just like algebra is a topic that we have started right from primary school, but you don't know that you are doing algebra. For instance, you have a plus, in primary school you have something like this, plus 3, and then which equals to what, 5. You ask what you have inside the box. So that would be what? What number will you add to 3 to give you 5? That's going to be what? So that is 2 plus 3 equals what, 5. So meaning that we have used a symbol. So sometimes you see they will put something like this, plus 5 equals to 7. You understand? We have used symbols here to represent what? Number. So that's what we call algebra. But as you progress along your journey, you are going to we change the symbol to letters. Thereby we make use of x, we make use of y. We have y minus 5 equals to what? 12. That is, what number must be subtracted from 5, or what number will 5 be subtracted from to get what? 12. So that is the value of y. So the y here is representing a number. So this all refers to as algebra. So algebra is a branch of mathematics in which letters of alphabets or symbols are used to represent what? Numbers. I hope that is very clear. Now, having said that, so that is the meaning of algebra. Then we now go to key concepts. There are some concepts you must understand in algebra that will make you to understand the next or the subsequent topics we're going to be treating under algebra. Understanding of these key concepts will help you a lot in having or grip of what algebra is. Because some students, they believe that algebra is very hard. But I want to tell you that algebra is one of the simplest topics in mathematics. So what are the key concepts? The first one is, let me write, key concepts. Key concepts. So the first one I'm going to talk about is variable. Variable. So variable here are variables. So we still saying the same thing. You know, I said when I was defining algebra, I said we are using what letter or symbol to represent what number. So any letter you see in an expression is what refers to as variable. Letters. So variables are letters. So variables are letters. These are letters. These are what? Letters. These are letters that represents numbers. That represent numbers. Now, for instance, example, we have 2x. So this x here is a variable. It's representing a number which we don't know, that is 2. So when you have 2x in this form, so the same thing as saying 2 times what? X. So that is 2 is multiplied by a number which we don't know. So this x here is what we refer to as what? Variable. This is a variable. Alright? So this is a variable. And we can have letters. We can have some example. We have 3a squared b. So a and b here are also what? Variables. I hope I'm making sense. These are also what? Variables. So because a is representing a number here, while also the b is also representing what? A number. I hope I'm making sense. So any letter you see in a mathematical expression, refers to them as what? Variables. I hope that is very clear. So that is that for the first one. The second one is coefficient. Coefficient. Now, coefficient here is the number we have beside a variable, or the number we have or in front of a variable. For instance, let me pick these 2x. These 2x it has a name as well. But these two here is the coefficient of the letter of the variable. So coefficient is the number that is attached to a variable. The number that is what? Attached to a variable. So that coefficient could be positive number, it could also be a negative number. It could be decimal, it could also be what? Fraction. So it depends. So it is the number that is attached to a variable. So we write it is the number. It is the number in front of a variable. So for example now, so we have 2y squared. So the coefficient here is 2. We have 0.5 x. This is also a coefficient. And we can also have 1, 2 all over 5 b squared. So you can see the variables here are y, x, and b. So the number that is attached to them, which is this, and this. So this could be, let's say this one is minus 0.5. So all these ones are what? Coefficients of the variables being attached to the coefficients. So which means 2 is the coefficient of y squared here, while minus 0.5 is the coefficient of what? X, and then 2 over 5 is the coefficient of what? B squared. I hope I'm making sense. So that is that on that one. So then the next one we're going to look at is 10. 10. This is the third one. 10. When we talk about 10, 10 it could be a variable that's standing alone. It could be a variable and coefficient, and it could be a constant. So these are the three, or both. So for example, you have a 10, let me write it. A 10 is either a variable, a coefficient, and a variable, or a number. Now, so for example, you have this 2xy plus 3x squared minus 4. This as a whole is a 10. You can see it is a combination of, let me put another one, plus z. This is a combination of a coefficient and variables. So this is a 10. This is a coefficient and what? Variable. This is also a 10. So this is a 10. While 4 here is standing alone, this is also a 10. Z here, which is a variable, is also what? Standing is a 10. So all of them here, all of them, 4 of them here are 10s. They are all 10s. So this is what we call 10s. And one thing you must take note of under 10 is that 10s are separated. 10s are always separated by plus or minus. So between this 10 and this 10, you must have what? A plus or a minus, not multiplication. Because this itself is multiplying. That is 2 is multiplying x, it's also multiplying what? Y. 3 is multiplying x and also multiplying another x, making x squared. 4 is standing alone, z is also standing alone. All these ones are what we call terms. So understanding of these basic concepts or key concepts will help you a lot by the time we go into the details of what? Algebraic processes. Am I making sense? So that is that on that. Then the last one that I want to share with you under the key concepts is what we call expressions. Expressions, not English expression. This is what we talk about. We're talking about mathematical expression, which is referred as algebraic expression. But in short form, We call it what? Expression. Expression. Now, you can see one after the other. All of them, they are what? Interwoven. So expression is the combination of terms. Expression is what? Combination of what? Terms. You notice that when we started with variable. Variable, then we go to the coefficient. So coefficient and a variable gives us what? 10, or variable alone, or whole number alone, this or numbers alone. We give us what? 10. But now expression is when we combine different terms together, just like this one. Everything here, everything, without separating them, all of them, we regard to this as what? Expression. So if we now have the one that has equals to, it will now be what? Equation. It will what? Become what? Equation. But there is no equation there. That is, we refer to this as what? Expression. So expression is the combination, is the what? Is the combination of terms. Combination of what? Terms. So we can also refer this expression as algebraic what? Expression. This is an algebraic expression. So example of this is 1. So we can have 3x squared y plus 4x minus 5. So this is an expression. So this, and you can see that this is a term, this is also a term, this is also a term. So in a term we have a constant and we have variables or variable. So this one is a constant, this is a coefficient and variable. This one is also a term, it's just a constant, standing alone. So this is a constant. So if they ask you what is the coefficient of x squared y here, it is 3. What is the coefficient of x here? It is 4. That is, if the variable they are mentioning, just look at it. What do you have beside that variable? To tell you what the coefficient of that variable is. Let me give you another instance. We have minus x. You can ask what is the coefficient of x in this case? What is the coefficient of x in this case? So you'll be looking. There is no letter beside, there is no number beside it. But there is a number beside it. How many x is this one? It's minus 1x. But that one is invisible. So we don't write the 1. Just like we have banana, a banana, and what? One banana. Or a mango, and what? One mango. So you can just say I have a mango. I have one mango. You are saying the same thing. So that one, if you drop it, so your expression is still correct. But here, the same thing with math. So if you say 1x is correct, x is also correct. So here, the coefficient of x here, the coefficient of x is what? Minus 1. Because the minus will also always go with it. So the sign in front of that number will always go with that coefficient. How this is very clear. So these are the key concepts you need to understand very well under algebra. Then we now move to simplifying expressions. But there are some things I want to take note of before we move on. Terms, I've said that under expression, let's take note of this. Take note of the following. Right. Let's take note of the following. Note this. Note this. So terms are linked by plus or minus signs. That's the first one. Terms are linked by what? By plus or minus what? Minus signs. Then the second one is, so in a term, numbers are what? Are written first. So, for example, you can see number comes first, followed by letters. So, not that you write x, 2, 1. No. So, number will come first before the letters. And the letters are written first. The letters are written alphabetically. So, 3 letters are what? Are written alphabetically. I hope I'm making sense. So that is very important. So the next one now is for us to look at simplifying expressions. Simplifying expressions. When you ask to simplify an expression, you ask to reduce the expression to its lowest term. Anytime you hear the word simplify, it means reduce or take it to the lowest term. So an expression, so let's write, to simplify an expression, to simplify an expression means to reduce the expression to simplest form. To simplest form. I hope that is very clear. So let's look at examples now and see what is meant by that. And what it means is that this could be through addition. It could be what? It could be through adding. That is through addition or subtraction or multiplication, right? Or division. So all these will happen when you are simplifying what? Expression. So let's look at examples here. Examples. Let's look at these examples. Simplify the following. The first one, 3x plus 5x, 2, 12b minus 5b, 3, 7x minus 3x plus 5x, 4, 2a plus 5a minus 4a plus a. Then the fifth one, 7y minus 5y minus 3y plus y. So let's look at this. So what this means, we have to simplify this. We want to reduce it. It's too long. So for us to do this, what it means is that 3x plus 5x. Please take note of this. 3x, you can take it to real life. You can say 3 oranges, 5 oranges. Making how many oranges? 3 plus 5 gives us what? 8. So in that case, 3x plus 5x will give us what? 8x. I hope that is very clear. We can apply that so that you get it correctly. Then the second one, 12b minus 5b. You can see that it's now 110. 110. We have 2 10s here. We have reduced it to what? To 110. So we have 12b minus 5b. So we can change this one to 12 bananas minus what? 5 bananas. Out of 12 bananas, take 5 out of it. So what we have left? We're going to have 7 banana left. You can see that it's very simple. Alright? Then the third one. We have 2a plus 5a minus 4a plus a. Now in this case, we are going to do something. You notice that here we have just plus, here minus, here we have minus and plus. So when you have minus and plus together like this, what you are expected to do is to rearrange it. Bring all the plus together and take all the minuses, bring them together too. Then add them together, then subtract. So what we are saying in essence is that we are going to regroup. We regroup the positive and the negative. So this is positive, positive, and positive. Let's bring all of them together. So 2a plus 5a, that is 7a plus a. We are going to say 2a plus 5a plus a minus 4a. So 2a, that is 2 apples, 5 plus 5 apples, plus apples, then plus 1 apple. So making how many apples? 8 apples. That is 8a. Minus what? 4 apples. So we are now removing 4 apples from this. So that will give us what? 4a is 4 apples. I hope this is very clear. Alright? So let's 2a Oh, sorry, I did 4 in place of 3. So I'm going to do 3 now. So that is 3 is 7x minus 3x plus 5x. The same thing here. We bring the positive together. That x, 7x plus 5x minus 3x. Add this together. This gives us 12x minus what? 3x. When you subtract, you get what? 9x. Then the final one, which is number 5, is 7y minus 5y minus 3y plus 4y. So let's see how we're going to do that. 7y minus 5y minus 3y plus what? Y. Now here, this 7y, the sign we have in front of it is plus. The sign we have in front of this one is also plus. We bring the two of them together. That is 7y plus y. Then minus 5y minus 3y. So 7y plus y gives us what? 8y. Are you with me? Then minus 5y minus 3y. So minus 5y, you are owing 5, you are also owing 3. That gives us minus what? 8y. Or if you don't want to do it that way, you can have it to be 8y minus 5y minus 3y. You can do it separately. Let's do it this way. So 8y minus 5y minus 3y. So we can have it 8y minus 5y gives us 3y, then minus 3y. So this will give us 0. So it will not be 0y. You can't have 0. It's just like when you say 0 pen. No. So since you don't have it, you don't have pen. That is 0. So there's something like 0 pen. There's 0 naira. Nothing like 0 naira. No money. No naira. Exactly. So this is it. Or we have it to be or we have it to be 8y minus 8y, which is equal to what? 0. All this is very clear. So all right, collecting like terms. That's the next thing. You can see what I told you. The terms that we discussed is now coming out. We don't see the usefulness of this now, understanding it. Now let's look at the example. Collecting like terms, that the terms that look alike, we bring them together and perform the operation. So let's see how we do that. So let's look at these examples. Simplify. It's when we see simplify. Examples. Simplify. The first one, 5y plus 4x plus 7y plus y plus 6x. And the second one, 8a plus 5b minus 5a minus 3b plus 2. Then the third one, have 4g minus 6h minus 5g minus 3g plus 10h plus 6g. So let's look at these 3 examples and see how we're going to solve them. So solution here. Now the first one is 5y plus 4x plus 7y plus y plus 6x. What you are going to notice here is that we have more than one variables. Unlike the one we have been solving before, you can see that the variables we have here, they are just one. This is a term, right? But here we have 2 variables in this one. And sometimes you can have more than 2 variables. You can have 3 variables or 4 variables. So the same process will apply. So in this case, we are going to collect the like terms. We bring all the ones that look alike. Y, bring them together. Then x, bring them together. So that is going to have 5y. So the sign before them will not change. Plus 7y plus what? Y. Then we are done with that. We have taken this, we have taken this, we have taken this. It remains this and this. That will be plus 4x plus what? 6x. Then perform the operation. So we add this together. 5y plus 7y plus y. So this plus this gives us 4 plus 1. That gives 13y. Because this y here is 1y. So that gives this one to be 13y. Then plus 4x plus 6x. That gives us plus 10x. Plus 10 what? X. So you ask me, are you going to add this together? No, you're not going to have this final answer. Why? Because we cannot say 2 boys and 3 girls. 2 boys and 3 girls. We want to add them together and now say, oh, 5 boys, girls. No, it sounds odd, right? So we can't add. So once they are not the same, they are different. Y is different from X. You can't add nor subtract the 2 of them together. But when we get to multiplication, you can see, you can understand some other things there. We can multiply them together. But in this case, you leave your answer like this. How about very clear? So that is that one. Then number 2, so we have 8a plus 5b minus 5a minus 3b plus 2. So the same thing we have from here. We're going to collect the like terms. We bring them together. So that means this and this will come together. That's going to be 8a. You can see the 5a is having minus. If you go with it, minus 5a. Please take note of that. This minus belongs to what? To 5a. Then we are done with it. We've collected all the a's. Then it remains b. So this and this, they are b's. So this is plus 5b, then minus 3b. You can see 2 is standing alone, so it has no partner. Is that clear? So we just put plus 2 there. Alright, so in that case, 8a minus 5a, that is going to give us 3a. All this is very clear? Alright. Then 5 plus 5b minus 3, that's 5 minus 3. That's going to give us plus 2b. Then plus these 2. That gives us the answer. We cannot add 3a and 2b together and say 5ab. No, it is wrong. That is that on this one. So the last example we have there, example 3. So we have 4g minus 6h minus 5g minus 3g plus 10h plus 6g. Because this one is very long, but it doesn't matter. So what you can see, notice here is that we have 2 variables which are g and what? H. So we're going to collect like terms as well. So we bring all the g's together. That is 4g, 5g, 3g, and 6g. But when you are bringing them together, you have to put the positive, the plus, the one with plus signs together first. That is 4g plus 6g, then minus 5g minus 3g. Is that clear? Again, so you are going to combine 4g plus 6 because this is plus plus, then minus minus, then h. This is 10h first, then minus 6h. So this and this, and that is all. So let's now perform the operation on them. So 4g plus 6g gives us 10g. Then minus 5g minus 3g, that is minus 8g. You are owing 5, you are also owing what? 3. That gives you 8. That's minus 8g. Then plus 10g, 10h minus 6h. That gives what? 4h. So that means that 10g minus 8g gives us 2g plus 4h. I hope this is clear. So that is the final answer. We cannot add, we cannot subtract, because g and h are not the same. So we can say 2g plus 4h equals to 6gh. Just like saying 2 boys plus 4 girls equals to 6 boys girls. That would be very, very wrong. The same thing in mathematics. We cannot add the 2 of them together. So that is that for this video. So in our next video, we look at another concept under algebraic processes. So we are going to meet in our next video. Bye for now.